everyone. In today's class, we are discussing p block elements. Last class, we are discussing p block elements. In that chapter, oxides of p block elements. In previous class, we are discussing oxides of p block elements and its classification. Generally, p block elements oxides are classified into different types. They are basic oxides, acidic oxides, amphoteric oxides, neutral oxides, and mixed oxides, peroxides, superoxides, and suboxides. And in last class, we are discussing oxides of carbon. Generally, carbon forms two types of oxides. They are carbon monoxide and carbon dioxide. And next, oxides of nitrogen. Generally, nitrogen react with oxygen and it forms different types of oxides. They are nitrous oxide, nitric oxide, dinitrogen trioxide, dinitrogen tetroxide, and dinitrogen pentoxide. These are the oxides of nitrogen. And next, oxides of phosphorus. Generally, phosphorus react with oxygen and it forms different types of oxides. They are phosphorus trioxide, phosphorus tetroxide, and phosphorus pentoxide. So in today's class, we are discussing oxides of sulfur. Oxides of sulfur. So here, oxides of sulfur. So there are two types of oxides of sulfur are SO2 and SO3. Here sulfur reacted with oxygen and it forms two types of oxides. They are sulfur dioxide and sulfur trioxide. In that, first we are discussing sulfur dioxide. So here, when sulfur dioxide decomposes at 1200 degrees centigrade temperature and it forms sulfur and sulfur trioxide. When SO2 sulfur dioxide decomposes at 1200 degrees centigrade temperature and it forms sulfur and sulfur trioxide. So this is the reaction of decomposes of sulfur dioxide. Here 3 moles of sulfur dioxide decomposes to form sulfur and 2 moles of sulfur trioxide. And next reaction, here generally carbon, iron and magnesium elements when heated at 1100 degrees centigrade to form carbon dioxide and sulfur. When at 1100 degrees centigrade temperature, carbon, iron and magnesium elements heated to form carbon dioxide and sulfur, or sulfur dioxide reacted with carbon element or iron element or magnesium element at 1100 degrees centigrade temperature and it forms carbon dioxide and sulfur. So here in this reaction, SO2 sulfur dioxide reacted with carbon at 1100 degrees centigrade temperature and it forms CO2 carbon dioxide and sulfur. So the next one, structure of SO2 sulfur dioxide. So here generally in SO2 sp2 hybridization is present and it is a angular in shape. Generally SO2 undergoes sp2 hybridization. Sulfur dioxide undergoes sp2 hybridization and in this SO2 it is having angular shape. So this is the structure of SO2 sulfur dioxide. The next one, sulfur trioxide, SO3. So here generally it is available in alpha, beta and gamma forms. The sulfur trioxide is available in alpha form, beta form and gamma form. It is decomposes at 1000 degrees centigrade temperature and it forms sulfur dioxide. Sulfur trioxide is available in alpha form, beta form and gamma form when it is decomposes at 1000 degrees centigrade temperature and it forms sulfur dioxide. So this is the reaction of decomposes of sulfur trioxide at 1000 degrees centigrade temperature and it forms sulfur dioxide. The next, this is the structure. So here generally in sulfur trioxide it undergoes sp2 hybridization and it contains 3 resonance structures. Generally SO3 undergoes sp2 hybridization and it contains 3 resonance structures. So these are the resonance structures of sulfur trioxide. So here S double bond O and oxygen, this is a one type of first compound, and SO double bond O, this is the second structure, and here S double bond O, this is the third structure. These 3 are the resonance structures of sulfur trioxide. So this is the oxides of sulfur. Sulfur forms 2 types of oxides. They are sulfur dioxide and sulfur trioxide. The next one, we are discussing oxides of chlorine. Oxides of chlorine. So here generally chlorine reacted with oxygen and it forms different types of oxides. Chlorine reacted with oxygen and it forms different types of oxides. In that, first chlorine monoxide, Cl2O. So here the general formula of chlorine monoxide is Cl2O. When it is hydrolyzed to form hypochlorous acid, chlorine monoxide undergoes hydrolysis to form hypochlorous acid, hence it is known as anhydride of hypochlorous acid. Here generally the chlorine monoxide general formula is Cl2O, and this chlorine monoxide undergoes hydrolysis, it forms hypochlorous acid. That's why this is called as anhydride of hypochlorous acid. So this is the reaction of chlorine monoxide undergoes hydrolysis and it forms chlorine monoxide. The next one, chlorine dioxide. So here generally the chlorine dioxide formula is Cl2O, Cl2, chlorine dioxide. So here the chlorine dioxide, an orange red gas at normal temperature. Chlorine dioxide is an orange red gas at normal temperature. When it is hydrolyzed to form chlorous and chloric acid, so it is a mixed anhydride. The general formula of chlorine dioxide is ClO2. At normal temperature, the chlorine dioxide is a orange red gas. This chlorine dioxide undergoes hydrolysis to form chlorous acid and chloric acid. That's why the chlorine dioxide is called as mixed anhydride. So this is the structure of chlorine dioxide. The next one, chlorine trioxide or chlorine hexoxide, ClO3, chlorine trioxide, or Cl2O6, chlorine hexoxide. So here the general formula of chlorine hexoxide is Cl2O6. Here when it is dissolved in water, it forms chloric and perchloric acid. Generally, the chlorine trioxide or chlorine hexoxide, it undergoes hydrolysis or it is dissolved in water and it forms chloric acid and perchloric acid. Hence, this is also known as mixed anhydride. This is also called as mixed anhydride. So this is the structure of chlorine hexoxide, ClCl, 2 moles of chlorine and oxygen, 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 Cl2O6. So this is a chlorine trioxide. The next one, dichlorine heptoxide. Dichlorine heptoxide. So here the general formula of dichlorine heptoxide is Cl2O7. When Cl2O7 undergoes heating, decomposes with explosive sound. When Cl2O7 undergo heating, decomposes with explosive sound. It when undergoes hydrolysis to form perchloric acid. So that's why the dichlorine heptoxide is an anhydride of perchloric acid. So this is a dichlorine heptoxide. Here the general formula of dichlorine heptoxide is Cl2O7. When it is undergo heating, decomposes with explosive sound and it undergoes hydrolysis to form perchloric acid. That's why the dichlorine heptoxide is called as or is known as anhydride of perchloric acid. So this is the reaction of dichlorine heptoxide. Cl2O7 undergoes hydrolysis to form HClO4, 2 moles of HClO4, perchloric acid. That's why this is known as anhydride of perchloric acid. Next, this is the structure of Cl2O7, dichlorine heptoxide. So these are the oxides of chlorine. The next one, oxy acids. So here generally oxy acids means the oxides of high electronegative elements react with water to form oxy acids. Generally the oxides of high electronegative elements reacts with water molecule to form oxy acids. These exhibits thermal stability. These are exhibits thermal stability. Then next, oxy acids of boron. Next we are discussing oxy acids of boron. So here generally boron forms these types of oxy acids. They are metaboric acid HbO2, orthoboric acid H3BO3, pyroboric acid H6B4O6 and tetraboric acid H2B4O7. Boron forms these four types of oxy acids. So here the next we see the preparation methods. So here B2O3 boron trioxide reacted with water molecule and it forms HbO2, 2 moles of HbO2, that is metaboric acid. Boron trioxide undergoes hydrolysis to form metaboric acid. The next one, this metaboric acid HbO2, metaboric acid undergoes hydrolysis to form H3BO3, that is nothing but orthoboric acid. Orthoboric acid. Then next, boron nitrate. Boron nitrate undergoes hydrolysis to form H3BO3, orthoboric acid. Boron nitrate reacted with 3 moles of water molecule and it forms orthoboric acid. And the next, Na2B4O7 reacted with HCl, it undergoes hydrolysis to form orthoboric acid. It forms orthoboric acid. Then next, this structure, it has planar structure. Boron having planar structure. So this is the structure of boron oxides. Boron oxides. The next one, oxy acids of carbon. So here generally in oxy acids of carbon, carbon monoxide is a neutral compound. In oxy acids of carbon, carbon monoxide is a neutral compound and carbon dioxide form carbonic acid. Carbon dioxide forms carbonic acid when it is dissolved in water and it forms carbonate and bicarbonate salts. In oxy acids of carbon, carbon monoxide is a neutral compound and CO2, carbon dioxide, forms carbonic acid. This carbonic acid, when it is dissolves in water, and it forms carbonate and bicarbonate salts. It forms a carbonate and bicarbonate salts. So here this is the reaction. H2CO3 reacted with NaOH and it forms NaHCO3, sodium bicarbonate, and here 2 moles of sodium hydroxide reacted with H2CO3 and it forms Na2CO3, sodium carbonate. So here carbon dioxide undergoes hydrolysis, it forms carbonic acid, and this carbonic acid reacted with base, it forms carbonate and bicarbonate salts. So here carbon in carbonate ion shows sp2 hybridization and it forms triangular planar structure. Generally in carbonate, the carbon ion shows sp2 hybridization and it is having trigonal planar structure. It contains trigonal planar structure. So this is the structure of These are the resonance structures. These are the resonance structures of oxy acids of carbon. So the next oxy acids of nitrogen. So here nitrogen forms 6 types of oxy acids. Generally the nitrogen oxy acids of nitrogen, the nitrogen forms 6 types of oxy acids. They are hyponitrous acid, hyponitrous acid H2N2O2. The next one nitroxylic acid H4N2O4. The next one nitrous acid HNO2. And fourth one hyponitric acid H2N2O3. Fifth one nitric acid HNO3. Sixth one pernitric acid HNO4. These are the oxy acids of nitrogen: hyponitrous acid, nitrooxylic acid, nitrous acid, hyponitric acid, nitric acid, and pernitric acid. In these 6 types, first we are discussing hyponitrous acid. Here the general formula of hyponitrous acid is H2N2O2. The general formula of hyponitrous acid is H2N2O2. It is a white unstable substance. Hyponitrous acid is a white unstable substance. This hyponitrous acid decomposes in air and forms nitrous acid and nitric acid. Here the hyponitrous acid is a white unstable substance. It undergoes decomposes in air and it forms nitrous acid as well as nitric acid. So here this is the reaction of hyponitrous acid. Here 2 moles of H2N2O2 hyponitrous acid, it decomposes in air and it forms nitric acid and nitrous acid. Here 2 moles of H2N2O2 reacted with 3 moles of oxygen and it forms 2 moles of HNO3 nitric acid and 2 moles of HNO2 nitrous acid. And here it is reacts with base to form 2 types of salts. These hyponitrous acid react with base and it forms 2 types of salts, that is H2N2O2. Hyponitrous acid reacted with potassium hydroxide, 1 mole of potassium hydroxide and it forms KHN2O2, potassium hydrogen hyponitrate, potassium hydrogen hyponitrate salt. So here byproduct is water. The next one hyponitrous acid reacted with 2 moles of potassium hydroxide and it forms K2N2O2, potassium hyponitrate, and byproduct is 2 moles of water molecule. So here this is the hyponitrous acid. Hyponitrous acid formula is H2N2O2. It is a white unstable substance. It is decomposes in air and it forms nitrous acid and nitric acid. When it is react with this hyponitrous acid react with base, it forms different types of salts. It is react with 1 mole of potassium hydroxide, that is base, and it forms potassium hydrogen hyponitrate. And when it is react with 2 moles of base, that is potassium hydroxide, and it forms potassium hyponitrate. Potassium hyponitrate. So the next one, structure of hyponitrous acid. So here generally the hyponitrous acid shows cis trans forms. Hyponitrous acid shows cis trans forms. So here N2 and OH. So here 2 moles, 2 nitrogens, 2 oxygens and 2 hydrogens. So here these are the same side, that's why that is called as cis. Here OH is opposite side, that's why that is called as trans. So here this hyponitrous acid shows cis trans forms. So this is the hyponitrous acid. The next one, nitrooxalic acid. Nitrooxalic acid. So here this nitrooxalic acid, it is an explosive unstable acid. This nitrooxalic acid is a explosive unstable acid. It should be stable in the form of salts. Nitrooxalic acid is a unstable, explosive unstable acid. It should be stable in the form of salts. It should be stable in the form of salts. The next, hyponitric acid, H2N2O3. Hyponitric acid. So here the general formula of hyponitric acid is H2N2O3. When it is decomposes to form nitric acid, this hyponitric acid, when it is decomposes to form nitric acid. The next one, nitrous acid, HNO2. So here the general formula of nitrous acid is HNO2. Here this nitrous acid dissolves in water and it forms salts. When it is dissolves in water, it forms a salts. And the next, it is reduces KMnO4 and K2Cr2O7 and chlorine. When it is dissolves in water, it forms a salts and it reduces KMnO4, potassium permanganate, K2Cr2O7, potassium dichromate and Cl2. The next, this nitrous acid, it is oxidizes hydrogen iodide into iodine and tin dichloride to tin tetrachloride. This nitrous acid oxidizes hydrogen iodide into iodine and tin dichlorine to tin tetrachlorine. So these are the reactions. When it is dissolves in water, it forms salts. It is reduces KMnO4, K2Cr2O7 and chlorine, and it is oxidizes hydrogen iodide to iodine and tin dichlorine to tin tetrachlorine. So the next, this is the structure of HNO2. Structure of HNO2. The next one, nitric acid. So here the general formula of nitric acid is HNO3. So here HNO3 is a liquid. The boiling point of HNO3 is 121 degrees centigrade. HNO3 is a liquid compound and the boiling point is 121 degrees centigrade. It is oxidizes H2S, hydrogen sulfide, into sulfur dioxide into H2SO4, and ferrous salts into ferric salts. It is oxidizes H2S into S, hydrogen sulfide into sulfur dioxide into H2SO4, and ferrous salts into ferric salts. So these are the reactions. And when it is react with copper to form NO, here 3 moles of copper reacted with 8 moles of HNO3 and it forms copper nitrate compounds as well as nitric oxides. And it is reacts with concentrated HNO3, I mean copper reacted with concentrated HNO3 and it forms NO2, nitrogen dioxide. Here HNO3 is a liquid compound. The boiling point of HNO3 is 121 degrees centigrade. When it is oxidizes hydrogen sulfide into sulfur dioxide into H2SO4, and ferrous salts into ferric salts. When it is react with copper and it forms nitric oxide, and this copper reacted with concentrated HNO3 and it forms nitrogen dioxide. And here the nitrogen in HNO3 shows sp2 hybridization. In HNO3 the nitrogen shows sp2 hybridization and it is having planar structure. It is having planar structure. So this is the structure of HNO3, nitric acid.